Number one is the square root of 10 times the square root of 5. So we have, you multiply the numbers underneath it, so you get the square root of 50. Then you have to look for a perfect square. So what is a perfect square that goes into it? If you don't remember your perfect squares, you're looking at 1 squared is 1, 2 squared is 4, and yes, 5 squared is 25. So we have the square root of 25 times the square root of 2. Square root of 25 is 5 square roots of 2. We are looking now at my 192. So you're looking for your cubes. 1 cube is 1. 2 cubed is 8. 3 cubed, is it 27? 4 cubed, and yeah, 4 cubed. So 4 cubed is 64, and 5 cubed is 125. All right. So we know that 125 doesn't go into 192. So go to 64. 64. Does 192 divide by 64? Yes. The cube root of 64 times what gives me the cube root of 3? And then we're going to leave underneath it the cube root of a to the 16, b to the 15. So, what is the cube root of 64? Is 4. This we're going to leave underneath it so we can keep it over here. Cube root of 3. If I was saying that 3 have to leave at a time and there's 16, how many groups can leave? 5. So you have a to the 5, and we have 1 person or 1a remaining. I have 15 b's. How many groups can leave? 5. So we have b to the 5 with nothing else. All right, when you are multiplying, remember all you do is you multiply what's underneath. So we have 5 times 2, which gives me 10. X to the 5th times x squared is x to the 7th. And we're taking the cube root of that. We know the cube root 2 cubed is 8, so 8 would be the biggest number that could go into 10, and it doesn't go in evenly, so we can't do anything with the 10, but we can bring out some of the x's. How many x's can we bring out? 2, which would be 6 bringing out, but 2 groups. And how many stay behind? 1. So underneath it we have 10x. On 4, what I would do with 4 is, the first thing I would do is reduce anything you can do. So, can we reduce 7 and 2? No. But we can reduce our x's. If we have 10 on the top and 4 on the bottom, how many x's would we have on the top? If we have 10 x's on the top and 4 on the bottom, you cross them out. If I crossed out 4 on the bottom, how many would I have left up here? 6. If I have 10 on the top of y's and I have 3 on the bottom, I would have 7. What is the rule? The rule says we can't have a square root on the bottom. Does anybody remember what we have to do? Multiply. So we have to multiply the top and bottom by the square root of 2. So the square root of 7 times the square root of 2 gives me the square root of 14. Then we have x to the 6th, y to the 7th, all over 2. One last thing we have to do is look to see, can we pull anything out? John, can we pull anything out?
Yeah.
So we can't on the numbers. What about the x's?
Yeah.
How many? 2 has to come out at a time. You have 6 people in the room. How many groups could leave? 3. So we have x third. If we had 7 people, again, 3 groups could go. However, 1 would stay back. What do we do with numbers? What has to be true to be able to add radicals? Does anybody remember? The same thing underneath it. So since this is the same thing, we can add our numbers in front. So we don't do anything to the numbers underneath. So we have 5 and 4 gives me 9. If at that point you could take some stuff out, you could do that, but there's nothing I can take out, so here is my answer. I want everyone to look at 6 and put an answer down. What do you think the answer to 6 is? Put an answer down, just like number 5. So these are the same. So you have 3 minus 4, which is a -1 square root, or the 4th root of 5a. It's a 4, because it stays the same thing. So it's negative 4th root of 5a. All right. Simplify. So we want to simplify this. Does anybody know what does it mean to be raised to the 1/3? It means the cube root. So this says the cube root of 8, and this is the cube root of 64. So we have, 2 times 8. Actually, I don't think it's 8. It's 4. Yep, 4. So 2 times 4 gives you the 8.
Right. Give the answer. You're right.
Oh, that's fine. Let me finish up this page, and then you guys can work on the back, and then we'll come back to that after lunch. When we are adding, remember, you only can add like terms. So i's are just like an x. Think about it like that. So you have the -5 plus your -3, which gives me a -8. -2i plus a -i would give me a -3i. So you can write it that way, or -8 minus 3i, however you want to write it.
But doesn't I have a value?
I is the square root of -1, but you'd never convert it back that way. The only thing you have to remember is that I squared is what? -1.
Oh.
You have to remember that I squared is -1, and we're going to use that in a moment.
So negative I squared would be 1, right?
No.
A squared.
No, if you have negative and then I squared. this, yeah, because that would be 1 as long as this is on the outside. All right, combining like terms again. I would personally distribute the negative. So you have -6 minus 4 gives me a -10. And then we have a -5 minus 3 gives me a -8i. You're combining like terms. And 10. -3 times your 4 is a -12. I times I is I squared. I squared is -1. So -12 times -1 gives you your 12. Now, what I would suggest is that you find the ones that are like this in your packet, and you can work on those this evening, or you can work on other stuff. But that's what I would do. After lunch, we're going to go through 11 through 20. So if I were you, what I would do for these few minutes is I would try to find problems like this in your new packet and do those problems.
So which ones are we going over in class? What's the review?
You know, those ones.
I am going over
The second one?